1 and 2, and then there was one more 4, then there was 5. Actually, it was a tie. So everyone put up a 4 or a 5, so, and then we'll decide. So 4, 1 there. So then number 1, number 2, and number 4. Okay, to find the line of best fit, you need to do that in Desmos. You could have also done that in your calculator, but Desmos would have been the easier option. So if you put in a table, put in all of your data. Then you can see your data, and to make your line of best fit, you need your y1, the squiggly line, the tilde, mx1 plus b. And it would tell you what that slope and y-intercept is. Use 3 decimal places, so y equals 0.891, x minus 0.87 round. And then for number 2, using number 1, find the milk consumption in 1 week of a 7-member family. So family size is, x. And we're looking for when x is 7. So if I type that in and I find where those 2 lines intersect, the gallons of milk would be 6.2, since all of these are to the 10th, and we were on that. Make sure you put gallons so you have labels. Questions on those 2? And then on number 4, this is very similar to the last shortcut you did, where you could have used the graph, but in order to do that, you would have had to solve this. So I'm going to do all of this in Desmos. By first putting in the ordered pair. Putting in the given equation.
He told me to do it. Okay.
And then on the given equation, I can find my slope by counting. So if I look at this by intercept, this is going up 1 to the right 2. And I keep doing that. So my slope, since it's parallel, it's going to be the same, 1/2. So I'm going to type in y equals mx plus b. Add in all my sliders. Change the slope to 1/2. And then move the b until it goes through that point. So then your equation would be y equals 1/2 x plus 2. And you would say you use Desmos. Or if you solve the equation and then use the graph, you could say use the graph. Or if you did it algebraically, solve the equation, use your point slope, and I would see your work. Questions on that? Gabriella, if you want to move so you're not by yourself, you can do that. Last class when I told you what we're doing today, I forgot that on the calendar it says that we're doing our notes today, and it also didn't take into account the 3 hours that we have. So we are going to do our notes first, and then we're going to do the SOL practice. So everyone should have those notes on their desk. And there was one thing that I forgot to mention when we were doing difference of squares. So somewhere where you have space, write down these two problems. This could be on the front, on the back, on the side, somewhere. As you missed last class, you should probably be paying attention. So write those two down. And this was in the differences, this should have been in the difference of squares section. So this is just a more complex version of that. We are still subtracting. Each piece in the fractions are still perfect squares. So how we do it is still the same. We're going to have two sets of factors. But when we break this down, we're going to look at the fraction and separate it by parts. So we're going to look at what times what will give us 1.
1 times 1.
1 times 1. And then what times what will give us 9?
3 times 3.
3 times 3. So separate that into both pieces. What times what will give us n squared?
N.
N. We have that first in both. And then we know the 1 part already. And what times what will give us 25? 5. And then put a plus, put a minus. So when you break that down, do it individually by numerator, by denominator of each fraction. So then what would the second one be?
2 over 5x minus 3 over 10.
And
2 over 5x plus 3 over 10.
so as long as you know what you're looking for, you can do this for any problem. I don't have many problems like this, but you could make up whatever fractions you want using your perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, keep going. Any of those, mix up the fractions, put different numerators and denominators, and do this. Questions on that? Okay, so now go on to the notes. So previously we talked about how to factor by GCF from any amount of polynomial, binomials, trinomials, polynomials. We talked about how to factor using difference of squares using binomials. And this method is factoring trinomials, so 3 terms. This is a specific method for factoring 3 terms. And this method specifically is for when the number in front of x squared is 1. So if this is the case, we can follow these rules. We're going to be looking for 2 numbers that multiply to be c, that add or subtract to be b. And in this, it's kind of like a puzzle. Only one set of numbers will work for this. So in number 1, we're looking for 2 numbers that multiply to be 12. So what are factors of 12?
3, 4.
3 and 4, 2 and 2. What else?
1 and 12.
1 and 12. And then of those pairs, we're looking for which ones when we add together would give us 7.
3 and 4.
3 and 4. So you're going to have 2 sets of factors, just like your difference of squares. Whatever the variable is going to come first in both. And if these were both positive, you're going to put plus 3 plus 4. If you want to double check your answer, you could distribute it back. X times x, I'm just going to write this off to the side, would be x squared. X times 4, 4x. 3 times x, 3x. 3 times 4 is 12. And when we combine our like terms, we get that original. So that works. So remember that the check part, that's optional. You can do that if you want. But really, you just need those 2 factors. Questions on how we found those? As you get used to this, as you get the hang of this, if you know the factors off the top of your head, that's great. If you need to list them all out, that's also fine. So number 2, we're looking for 2 numbers that multiply to be 20.
5 and 4.
5 and 4. I'm just going to list out all of them right now, but 5 and 4 would be the ones that work. What else?
2 and 20.
2 and 20. And?
1 and 20.
Sorry, that was supposed to be 1 and 20, and 2 and 20. Okay, and then which of those would add to be 9?
5 and 4.
5 and 4, so those 2 factors would be n plus 5, n plus 4. It doesn't matter if you put the plus 4 first or the plus 5 first, you just have to write both. We'll do one more of these types and then go on to another. Let's do number 5. 2 numbers that multiply to be 5. 5 and 1 is prime. And if these 2 numbers, the b and c values, are close together, like 1 apart, 1 is probably going to be one of your factors. So what would those 2 factors look like?
K plus 5.
Sure.
K minus 1.
Not minus. Plus. We're going to get into some minuses in a moment. Before we get into the minuses, the ones we skipped over, 3, 4, and 6, are there any of those we want to see do go over, have questions about?
Should we do 3?
Sure. Already come here. Factors of 18.
9 and 6.
Under 3 and 6, 9 and 2. What else?
1 and 18.
1 and 18. 1 and 18. If you're not sure what the factors are, start dividing. Whatever the number is, by 1, by 2, by 3. Keep going until the numbers are close together. Or if you look in between, 4 wouldn't work, 5 wouldn't work, and then where you end up with 6. So then of those, I forgot we were doing 3. Which of these would add to be 9?
3 and 6.
3 and 6. So those 2 factors would be what?
H plus 3 and H plus 6.
H plus 3 and H plus 6. So if you like rules and want to remember the rule, if you see 2 addition signs in your problem, both of your factors are also going to have 2 addition signs. Okay, let's look at number 7, where we now have a negative, a minus. Since we just found factors of 18, we don't have to do that again, but you do the same process. You find factors of 18, but because this is negative, one of these factors has to be negative, and then you're adding or subtracting to get positive 3. Which pair would do that? Which one would be negative? 3. So then those 2 factors would be n minus 3 and n plus 6. The general rule for this is if you see plus and then minus, one of your terms has to be a negative. The smaller one is usually the negative. Questions on that so far? Let's do another one. Let's do 10, and then I'll let you guys choose any others, and then we'll go on to the next type. In number 10, let's find factors of 54. You're gonna have to use your calculator, start dividing by 2, by 3,
6 and 9.
6 and 9. I'm gonna just list out all of them.
1 and 54.
1 and 54.
When you're doing like the actual like parentheses part, does it matter which number you put first in the negative?
This has to be negative, but whether you put minus 3 over here or minus 3 here, it doesn't matter. But you couldn't put minus 6.
3 and 8.
Not 3 and 8, but 3 and 18. There we go. What else? 27 and 2. Does 4 work?
No.
Okay. 5 doesn't work. 7 doesn't work. 8 doesn't work. Those are all of them. So then which of those could add or subtract to be positive 3?
6 and 9.
6 and 9. Which one would be negative?
6.
If you're not sure, check. Because if I did negative 9 plus 6, that would not give me a positive 3. So S minus 6 and S plus 9. Look at the other ones, numbers 8, 9, 11, 12, 13, 14. Any of those we want to see do go over.
So you're just looking at what adds up to 54?
Multiplies.
Oh, but like over on the one without the negative, you were looking at which one goes in top.
You're looking at which one multiplies to be the last, adds or subtracts to be the middle. Every time. Go on.
Can I put it back there?
Yes. Other questions we want to see in numbers 8 through 14.
17.
8 through 14. We'll do those in a minute. Okay, in number 13, find factors of 30.
6 and 5.
Okay, 15 and 2, 6 and 5. What else?
1 and 30.
1 and 30. 3 and 10. 3 and 10. 1, 2, 3, 4 doesn't work. 5 we have, and then 6. Okay, I think that's it. And then of those, which pair would we use? 3 and 10, which would be negative? 3. So x minus 3, x plus 10. Others up to 14 before we start 15 through 18.
14.
14, okay. Factors of 6.
2 and 3 and 1
2 and 3 and 1 and 6. Which of those could be used and which one would be negative? 1 and 6. Which one would be the negative? Negative 1. So A minus 1 and A plus 6. In 15 through 18, we have 2 negatives. The process still works the same. So like for 15, let's find the factors of 63.
9 and 7.
9 and 7. What else? 63. 63 and 1. What else?
3, 21.
3 and 20. What? 1. I could be right. Yeah. 3. Okay. I have to redo my tape because the whole board is messed up. Okay. And then we're looking for same thing. One of them have to be negative. which pair would we use? Which would be negative? Carry on.
9 and 7 and 9 and 8.
Yes. So in this case, 9 and 7, but 9 is now negative. So b minus 9 and b plus 7. So if you have a minus minus, one of them is still going to be negative, but the bigger number this time. Yes.
You're allowed to use all of those, right? 9 and 7, 63 and 1.
Not all of them would work.
Oh.
If I were to add, if I made one of these negative and I added them together, would they give you a negative 2? No. What about 3 and 21? If I made one of them negative and added or subtracted them together, would you get negative 2? So only one pair is going to work. Okay, other questions there? Which of the others do we want to see do go over? 72 has a lot of factors. What are those factors?
7, 2, 1.
Okay.
9 has 8.
9 has 8.
36 and 2.
36 and 2. There's some more in there.
6
6 and
and 12.
12. 18 and 4. There's one more. We have 9 and 8. So we have 1, we have 2, we have 6 already. Does 3 work? Okay. So which pair could we use and which one would be negative? 4 and 18. Which one would be the negative? Would negative 4 plus 18 give us negative 14? Negative 18. So x minus 18 and x plus 4. Any others in that section? Yes.
17.
17, we need factors of 64. Another one that has a lot.
8 and 8.
8 and 8.
12 and...
No, if it's 12, we could have looked at that one. 16 and 4.
3, 2 and 2.
3, 2 and 2.
1 and 64.
1 and 64. We have 8 and 8. I don't think 3 works. We have
9 and
4. 5 wouldn't work. Would 6
No.
or 7 work? Okay, so then that's probably it. And then which of those could be used? Which one would be the negative?
Well, negative 4 and 16.
Would then add or subtract to be negative 12?
Would it?
It would be negative 16.
It would be negative 16. Okay, plus 4, okay, minus 16. So be very careful, because if you put it the wrong way, that's not going to give you the right answer. If you were to multiply it back out, you would not get negative 12, you get positive 12.
I thought the negative had to be in the first one.
So that doesn't matter.
Just
Where
the
you
number.
put the negative does not matter. But in this case, the bigger number has to be negative. Look on the back. There's one last type of these. 2 more types of these, sorry. Where we have a plus at the end, so like 7, 8, 10, 12, problems like that. So for number 7, what are factors of 8?
2 and 4.
Okay.
1 and 8.
Okay. And then which of those could we add or subtract to be negative 6?
2 and 4.
How could we make it negative 6?
Negative 4. No, negative 2. Wait.
Negative 4, negative 2.
They both have to be negative. Remember that to get a positive, you could multiply 2 positives together or 2 negatives. So they would both need to be negative in this case. you have a minus and then a plus, they are both going to be negative. Any others we want to see from those four? 8, 10, 12. Alright, factors of 28. 4 and 7. 1 and 28. I don't believe there are others. Oh, and 2. Okay. Which factors could be used to add or subtract to get negative 11?
4 and 7. Negative 4 and negative 7.
Yes. X minus 4 and x minus 7. Notice if you put pluses here, you won't get negatives, so be careful. Yes.
How come for 17 got both negative?
The only way to add to get these negatives or subtract to get these negatives, they would both have to be negative. And if you multiply the two negatives, you get a positive. Other questions in that section, 10 or 12?
Can we do 12?
Sure. Factors of 36. 18 and 2, 12 and 3, 6 and 6, 9 and 4, 1 and 36, 1 and 36, 1, 2, 3, 4, no, 5, 6. And then which of those could we add or subtract to get negative 12?
Negative 6, negative 6.
Negative 6, negative 6, W minus 6 and W minus 6. Or because they're the same, you could write W minus 6 squared. Either or. Okay. The last row just has a mixture of variables, but the process is the same. If you wanted to see one of those after we do this next part, we could go back. But look at the very bottom section. So all of the ones that we've done so far have had just a 1 in front, but you may see something like this also, where you have to factor out a GCF. And whatever that GCF is most likely going to be the number in front. So if we have a GCF, if we were to divide each of these by 2, what would be left?
4 and 45.
2k squared divided by 2 for number 19. What would that first term be? The middle term would be?
Just k squared.
Just k squared. So k squared minus 4k minus 45. We would need 3 terms. We can't get rid of a term. Then the method is the same. We're looking for 2 numbers that multiply to be 45. Which would be 9 and 5. 1 and 45. Say that again. 15. Okay. And then which of those could be added or subtract together to get negative 4?
9 and 5.
Which one would be negative?
Negative 9.
9 would be 9. So k minus 9 and k plus 5. We're going to do one more of these. Any others you want to do? And then we're going to take a small break and then go on to the next part of the notes. And then we'll talk about the SL stuff. So in 20, you may not have a number in front, but you may have more x's than normal. So that x would be your GCF. If we divide each one by x, what's left?
X to the second plus 2x minus 48.
And then we're using the same rules. Factors of 48.
6 and 7.
Double check that. 6 is 1, but not 7.
6 and 8.
There you go. And you can list the rest, but 6 and 8 are actually the ones that work. Which of those would be negative?
6. 8.
Yes, 6 in this case. questions on how to look for the GCF? Factor that out first. Other questions in 21 through 24, or that last row, 16 through 18.
This is 22.
What would the GCF be for 22? What do those have in common?
2.
2. We could divide everything by 2. What would be left? X squared plus 5x plus 4. And then we're looking for factors of 4.
2 and 2. And 1 times 4.
And which of those would add to be 5?
1 and 4.
1 and 4. So x plus 1 and x plus 4. Other questions there? Okay, we're going to take a small 3 to 5 minute break. Get out of your seats. If you need to go get water, go to the bathroom. Now is the time to do that.
Can we just leave?
You can go to the bathroom, yes. Factoring by grouping works when there are 4 terms. So we just did trinomials. We did difference of squares with binomials. GCF could be with anything. 4 terms specifically, polynomials is grouping. So when we do grouping, you're going to group these terms together, group the first 2 together. You can use parentheses or you can just split it down the middle. And then we're going to find the GCF of both sides. So what do these 2 have in common? What can we divide out of these 2? 1. 1 is the number. What else do they have in common? X, how many? 2. X squared. To divide both by 1x squared, or just x squared. And we're going to see what's left. When you divide that out, what would be left? 7 for this part. What about this part? 1x. Then you're going to do the same thing to the second set. What can we divide out of these 2? 2. Whatever the sign is, you're going to bring that down. Make sure when you split it down the middle, the sign is with that term. So bring that sign down, divide them both by 2. And then what's left? X plus 7. What do you notice about this?
It's the same.
What's the same? The stuff inside the parentheses is the same. That's how you know you're doing this right. If the stuff inside the parentheses is not the same, something's off. And that should tell you, I need to fix something. Right? Then, once you have this factored out, everything on the outside, you're going to put together in a set of factors, in a set of parentheses, to be a factor. And then everything on the inside, you just bring that down once. You don't have to write it twice. Because it's the same thing, correct? And that would be your other factor. Then if you wanted to check yourself, you could double distributive FOIL box method this. X squared times x would be x to the third. X squared times 7. 7x squared. 2 times x. And 2 times 7. And this is the original. Those match, so I know we did that right. Questions on the process?
For step 2, like for the positive 2 outside the parentheses, how did that get there?
We divided both of these by 2, and this sign has to come down. Okay, now we're going to do some of these examples. Let's start with example 1. Split that down the middle. What do those first 2 have in common? 3x to the second power. I'm not gonna write that I'm dividing each piece. You guys can, but I won't have space. So if we divide both of these terms by 3x squared, what's left?
X to the third and
We're
plus
dividing
5.
by 3x squared, so just x plus
5.
5. What could we divide out of the last two? -2. So because we're dividing by a negative, the signs are going to switch. What would be left?
X plus 5.
X plus 5. The insides are the same, so I would bring my two outside factors, 3x squared minus 2 and x plus 5. And if I distributed everything, we get 3x cubed plus 15x minus 2x minus 10. It would match.
Looks hard.
Question so far? Okay, let's do number 2. After you split that down the middle, what's your next step?
Divide by
Divide what by 4?
8 and 12.
4x
Oh wait, what are we looking at?
number 2. So yes, divide the first two by 4x. What would be left? 2x plus 3. Guys, focus. What could we do with the second two?
By 1 or divide by 1x.
Divide by y. They both don't have an x. But we could divide both by y. What would be left? 2x plus 3. And then what would those two factors be? Not minus, but plus. 4x plus y and
2x plus 3.
2x plus 3. Let's look at number 4. I want you guys to walk me through how would we do this.
Divide by x to the third.
Divide what by x to the third?
X to the fourth and 4x to the third.
Okay.
Would be x plus 4. X plus 4. And then divide by 2.
Divide what by 2?
2x and 8. Would be x plus 4.
Like this.
With parentheses.
So like this.
Now, the
Put an x to the third outside of the first one.
Okay.
and then plus 2 in front of the x plus 4.
Okay.
And then you do x plus x to the third plus 4 in one parentheses. And then x plus 4 in the other.
Like this? What happened with the 2?
You have to
You put x plus 8.
x plus 2. X to the third plus 2 instead of 4.
It should be 4, okay. So when you are doing this, make sure you're using your parentheses, that you're bringing down all your factors, that you're not losing things, that you're putting the right factors. Any of those could make this mess up. Okay. Are there any others on this page you want to see you go over, have questions about? 9. 9 on the back. You want to do 9 on the back?
You do 5.
Or read about this one?
I was looking at
This one, okay. This one?
5.
We'll do those 2 and then go on to the back. So for number 5, if we split that down the middle, what could we divide out of the first 2? that it?
Y.
Y. What would be left when we divide those two?
2y
Minus 1. And then what could we divide out of the last two?
z.
Z. And would that be positive or negative?
Negative.
Positive.
Positive because of the sign. So plus z. We divide both terms by z. What's left? 2y minus 1. And then what are our two factors?
3y and z.
3y plus z and
2y minus 1.
questions there? Okay, number 8. Split that down the middle. What could we divide out of the first two? 2xy. What would be left? X plus 3. And then what could we divide out of the last two? Negative 1. If nothing else, you could always divide out a 1 or a negative 1. And then what would be left? And then our final factors.
2xy and negative 1.
And
X plus 3.
if at any point you think your numbers aren't right, double check it. Distribute, FOIL, box method to make sure you got the same thing at the beginning. Okay, go on to that. Any of those we want to see you go over and have questions about?
11.
Okay, we'll do 11, and then there's one I want to make up and one I want to show you. So with 11, if we split that down the middle, what would we divide out of the first two?
4rs.
4rs. What would be left?
R.
Minus 2. What could we divide out of the last two?
3.
Negative 3. What would be left? 1r. Not plus, but minus 2. And then our two factors.
4rs and negative 3.
And I don't know if we did this problem or not. I'll go back and look at it. So we didn't do 3, but these are the answers to it. If we got something like this at the end, but let's say this 5 was a 4. You have to factor these completely, as much as possible. So if you get something like this, that's your difference of squares, and then you would break that down more to x minus 2, x plus 2. And then you would still have that original x plus 2. So anytime you look at your final factors, you have to be thinking of all of your different factoring methods. Can I use GCF, difference of squares? Usually not a equals 1 because they usually don't end in trinomials, and usually not grouping as well, but definitely those two. And then we're going to do this last one. We're going to take this problem and I'm going to change it. Write this down.
Is that 1b or 16?
Negative 16. So we're going to do this just like normal, and then I'm going to show you how we could have done it at the beginning. So split it down the middle. What do the first two have in common?
R.
Yes.
8R.
8R and S. There we go. 8RS. Divide that out. What's left? R minus 2. What can we divide out of the last two? Positive or negative?
Negative.
Negative 6, what's left?
R. 2.
Minus 2, okay. And then when I make those two factors, we have 8 RS minus 6 and R minus 2. Looking at both of those, are both of those factors prime? No. So one of them, we could divide by 2. So one of them is not prime. So if you see something like this where it is not prime, you could divide something else out of it. You have to do that, otherwise it's not fully factored. So if we divide both of these by 2, we have 4RS minus 3, and then R minus 2, which, if you remember, that's what we got originally. But because we changed it, it now has a GCF. So you can either change that GCF at the end, or you can change it at the beginning. You just have to do it one of the two. You have to do it, otherwise it's not fully factored. If at the beginning you had seen that I could divide each of these by 2, you could have done that also. So if you had seen I could divide each of these by 2, you could have found the GCF, divided it out, and then did that problem from there. So be on the lookout for GCFs. Especially if you see bigger numbers. There's possibly a GCF. Okay. Questions on this? Okay. So what we're going to do next, there are 18 of you today. So I need 4 groups of 4. I need you guys to put yourselves in 4 groups of 4, and then there'll be 1 group of 2. Go ahead and do that, and then I'll explain what we're doing. We'll be doing a group math SOL practice. There are 4 roles, so your groups of 3, one of you will have 2 roles. There's the recorder, whoever writes down the answers on the sheet, wait. There's the runner, someone who's going to come get their answers checked, the group's answers checked. The reminder, someone who's going to remind everyone to be mindful of their manners, to make sure they're doing their work. There's the reviewer, make sure everyone has the right answer, understands how we got this answer, and that everyone agrees on the same solution. So I'm going to give you a minute to decide in your group who you want to do. Okay, let me get your attention back again.
What are you doing?
Waiting on everyone's attention. So I'm going to explain the scoring first, and then I'm going to pass out everything. So everyone's going to get a packet that looks like this. You guys are going to work section by section. Everyone should be working on the same section. Whatever section you want to start with, that's up to you. But everyone has to be working on the same. And then when you come up to get your section checked, if all of them are good, you get 2 points. If there are any that you need to fix, I'm going to circle them, highlight them. You're going to go back to your group. You're going to fix them. If you come back up and they're good, you get 1 point. If they're not, then you get no points, and I'm going to help you fix them. You can ask me general questions. There are some things we haven't talked about, so if you have questions about those, you can ask. Everyone has to put their names on the answer sheet, but only the recorder is putting answers on this, and only after you guys have talked through, this is the answer we choose. You shouldn't just be writing down answers. Yes.
Is this a grade?
Yes.
Oh my god.
Why would you ask that? Why would you ask that? Why would you ask that here?
Is this for grade?
Please should have questions.
I'm trying to eat.
Alright, laptops away. You guys can use Desmos. You can each use Desmos. There can be 1 group. I'll let you guys choose.
How many points do we like? Is the max points we get?
You'll see on your answer.
A C?
No, she was
You'll
see. You'll see.
You guys might have the same question, so listen.
Is it like a game? Like, is there a prize, or is it like the A?
This is your grade. So, Try to do as many sections as you can in the time remaining. If your group finishes, then you can have flex.
Oh, cool.
But if your group doesn't finish, then we're going to be finishing this next time I see you.
So have fun alone.